using vertex and intercept form. Those are the two easiest forms to graph these in. Okay? Everyone okay? Okay, so what does vertex form say? Who remembers? No one remembers? It says y equals a times x minus h squared plus k, right? Okay? So from there, there's a lot of information we can get just from that little equation. Okay? And since it's called vertex form, the main thing we can get is the vertex. So my vertex is HK. Okay, and just like remember when we graphed the V's, the absolute value, if it's inside the parenthesis, right, the number changes signs. If it's outside, it stays the same. So if we have an example, I'm just going to make one up. Y equals -1/4 x minus 2 squared minus 3. So my vertex for here would be h is -2, so it's going to be 2, -3. Yeah. Okay, very simple. No, I didn't. The inside changes. This is supposed to be positive h, right? And it's negative h in here. It's just going to be the 2. So it changes signs. Okay? So the inside changes. And the outside stays the same. A tells us whether it opens up or down. So it opens up if A is positive, and it opens -1/4, so it's going to open down, right? Everyone okay with that? Because it's -1/4. And it's not any of the numbers in here. It's always the number out here. Okay? Okay. And the next thing the last thing the A tells us is the stretch. And we'll talk about the stretch in just a minute. But my stretch here is 1/4. Okay? And I know it says -1/4, but I already used the negative in telling me if it's opening up or down. So it doesn't matter if I put -1/4 or positive 1/4. No, it didn't. Still running. Okay. Oh, it said I got an email.
What's the stretch?
The stretch, I'll explain that in just a minute. Okay. So there's the basic shape of the quadratic, right? We'll talk about what that does to the graph in just a second. Okay. It isn't in quadratics. It's not like rise over run in quadratics, okay, or in absolute values where it's rise over run. Okay, in quadratics it's not, because it's not quadratics. It's a curve, so it can't be the same every time, right? So, but it does affect it, and I'll show you how it affects it in just a second. Are you okay? Can you hold on just for a second? Okay. So that's all we can get from vertex form. Let's go to intercept form. Does anyone know what intercept form is? Yeah, it talks about the intercepts, and it's the x-intercepts this time, not y-intercepts. So the form says y equals a. We still have an a again. Guess what? The a has the same functions in this form that it has in the other form. Yeah, the a is exactly the same. Okay? So a equals x minus p and x minus Q. Okay? Not too bad, right? It's inside the parentheses, so guess what? They're going to change signs when I pull them out. Always, anything inside the parentheses, when I pull them out, changes signs. Everything's been like that, right? Okay, so my x-intercepts, not y, x-intercepts, are going to be P and Q. So if I have an example, 2x plus 3, x minus 5, sounds good, right? Okay. Okay. Oh yeah, that works. Okay. So I want to make sure it's even, so we don't fill with fractions right now. Okay. So P and Q. I don't care which one's P and Q. I don't care. I don't care. I know my x-intercepts are going to be -3 and 5. -3 and 5. Okay. We switch the signs. So if this is a +3, it becomes, and this is a -5, it becomes positive. They sign switch. Okay? When they're in the parentheses, the sign switch. Okay? There's actually a mathematical reason why they switch. And it's easier to show you on this one. It's the same reason on the other one, and I'll just show you, okay? Let's pick one without a 2, though. So if I have x plus 3, I'll just do it the same one without the 2 in front of it, okay? Right? And that equals 0. So my x-intercepts are where y in my, if I'm graphing it, right? My x-intercepts are here. What's the y value of this point? 0, right? So y equals 0. So I'm going to set y equal to 0 and solve for x. So if this equals 0, I'm multiplying two things together. And if it equals 0, that means one of them has to equal 0, right? Does that make sense? Something times something. The only way to get it to equal 0 is one of those something has to be 0. So then I can say x plus 3 equals 0, or x minus 5 has to equal, one of those two things has to equal 0. So solve for x. What do I do? -3. And I get x equals -3. What do I do on this one? Add 5. Good. And x equals 5. -3 and 5. Okay? It works the same. It's just a little more complicated on that one because we have the square involved. So you have to do square roots, blah, 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 blah. Works out exactly the same way. Okay? So the signs change if it's inside the parentheses. Are you guys okay with that? Does that make sense now? Okay. It's not just I'm telling you it changes just because it's in the parentheses. Okay? There's really a reason why it changes when it's in the parentheses. Okay? And that's why. Okay. Awesome. Okay. So we've got the x-intercepts. Now we want to find the axis of symmetry, which I did not talk about on Vertex form, which they will ask you about. The axis of symmetry is the line where it's symmetrical about. The only thing about the recording is they can't see all my nifty hand gestures, right? So axis of symmetry is where it goes through the x-coordinate of the, I didn't leave myself very much room, did I? The x-coordinate of the vertex, so x equals 2. Okay, so it's just the x-coordinate of the vertex, right? It splits the vertex in two. That's the x-coordinate. Axis of symmetry is really easy. On intercept form, it's a little harder. We're going to find the axis of symmetry by adding P plus Q. So, do I want to say axis of symmetry? It's the axis of symmetry and your x-coordinate. So let's say x-coordinate, because I like doing that one better. My x-coordinate is P plus Q It's the average of the two. So I take P and Q, divide it by 2 because the axis of symmetry is directly in between the 2 points, right? So I'm going to add the 2 together, divide by 2, finding the average. So it's -3 plus 5. 5 take away 3, divided by 2, 1. So my axis of symmetry, the x-coordinate is 1. Okay? I know, if we switch it around, you guys could do it, but I said -3 plus 5, and you're like, okay? Okay, so now how do I find the y-coordinate? Now we have to do a little bit more math on this one than on the vertex form. Vertex form is much nicer because it's just right there. This one I have to put the 1 into the equation and find out what my y is. So what's 1 plus 3? That's 4. Here, let me do this one in a different color. That's 4, right? And 1 minus 5? -4. So 4 times -4? -16 times 2? -32. So there's your vertex. Well, doesn't it say to multiply? Isn't that multiplication? Parentheses next to each other means what? Multiply. Okay? Good. There's your vertex. I took 1. X was 1, right? How did I get 1? I took P, which was -3, plus 5, and I divided by 2.
What are they giving us? Like, what do you not solve for?
Your intercepts, which are right here. Okay? They're not really given. You have to pull them out of the equation, right? Okay. And then you've got 3 points. You've got your vertex and your 2 intercepts. Draw your curve. Okay? 3 points for a quadrilateral, a quadratic, quadrilateral. A quadratic is okay. Okay? So this is going to make your life so much easier when we're graphing in any form. Once you have the vertex, this part right here, boom, you've got it done. Okay? So the basic pattern, I'm going to start with y equals x squared. That's my parent function, right, for a quadratic, x squared. That's what I'm doing. So let's just start with the table. If I have -2, that means that's -2 squared. I'm not going to, you guys all know what -2 squared, I'm not going to write it out there. Okay? I'm just going to leave it as -2 squared. Are you okay with that right now? -1 would be -1. 0 would be 0 squared. 1 is 1 squared. It's not 2. 1 squared is not 2. 2 is 2 squared. 3 is 3 squared. Are you guys okay with that? Right? Do you agree with this? Basic pattern, right? Okay. That's what it looks like on a table. So if I have my graph, and I'm graphing this, I have my vertex right here. I'll move out of the way so you guys can see. Okay, I have my vertex. If I'm just doing the bottom half, because it's symmetric, right, about this point, about this line, so I'm just going to do this half, the positive half. Are you guys okay with that? My first movement is to go over 1, up 1 squared, correct? Okay with that? That's what it tells me to do? Over 1, up 1 squared. How do I get to my next point? Start there, right? I go over, how far? 2, up 2 squared, right? You guys okay with that? The next, I think this one is got color in it. The next one says to do what? Start right here, go over 3, up 3 squared. Okay? Yeah, the yellow is kind of hard to see, sorry. It says 3 squared though. over 3 up 3 squared. Isn't that what it says? Over 3 up 3 squared. So now can you please grab that? So I'll just do it here. Over 1 up 1 squared. Over 2 up. Over 3 up. If I went over 4, how far would I go up? 5, 6. Got the pattern right? That's how it is? Yes, he's here. Okay, so this is the basic pattern for y equals x squared, yes? I go to my vertex wherever it's at. It does not matter where it's at. I'm going to go over 1 up 1 squared. Over 2 up 2 squared. Starting at your vertex. Always going back to your vertex. Go over 1 up 1 squared. Over 2 up 2 squared. Over 3 up 3 squared. Yes, honey?
Wait, why did we start with the positive?
It's because it's symmetric, right? Then I did the same thing. Over 1 up 1 squared. Over 2 up 2 squared. Over 3 up. Since it's symmetric, doesn't matter what side we go on. Okay? So what happens to this if I put an A out there? Which is what we normally have to graph. And this is where the problem comes in. Okay? Okay, so what happens to my pattern? Can anyone guess? Super hard. What does this mean? This is A times I'm still going to do my basic pattern, and then what am I going to do? Multiply by A. Doesn't matter. In this case, what's A? 1/4. In this case, what is A? Depends on the equation. Okay, once you have your vertex, and we're going to do some examples, okay, so this is just the basic pattern, so we'll do some examples. This is the basic, but if you remember 1, 1 squared, 2, 2 squared, it's not that hard. 1, 1 squared, 2, 2 squared, 3, 3 squared, right? Okay, if there's an A, we're going to multiply by A. Okay, so now we'll do some examples of how it works. And you guys can see it in motion. Are you guys okay with that? Okay, so any questions so far? Nothing? We good? And we can back it up mathematically. We'll put the points in. You can see how it works mathematically too, right? So it would match so you believe what I'm telling you. I just don't want you just to go, okay, she's right. Right? We should be able to prove it, right? And we will. I'll prove that it works to you. Okay? So here we go. What form are we in? Vertex form. So I always write down 3 things when I'm doing this. I write down what is my vertex? How does it open? What's my stretch? T-R-E-T-C-H. Oh, and we'll probably need to know your axis of symmetry. If you don't know what AOS is, write axis of symmetry. Okay? Okay. So what is my vertex? 2, 4. It's this number and this number. Okay? Is it going to open up or down? Down, because my A is negative. What's my stretch? What is A? 4. So my stretch is 4. And my axis of symmetry, x equals 2. So you go through the x coordinate of your vertex. Yes, honey?
Does stretch always reverse sign?
It doesn't. No. I just always put it as positive. You can put -4. It doesn't matter. Okay? That's the one case where the sign doesn't matter at. Because I already used the negative in saying my graph is going where? Down. So I already used the negative. Are you okay with that? Since I use my negative here, it doesn't matter if I use it here or not. Okay, it's not going to affect how I do my graph. Okay, so my vertex is at 2, 4. My axis of symmetry is, see, they want me to label the vertex and axis of symmetry, so I have to draw it in here. Lovely, lovely. It's opening down, so this is x equals 2. My vertex is 2, 4. Fantastic. Okay? Now the basic movement that we talked about, if I go over 1, how far am I supposed to go down? Right? I'm supposed to go over 1, up 1 squared. But now I have what? I have to multiply by a. So I'm going to multiply by 4. Okay? So what's 1 squared times 4? Anybody know what 1 squared times 4 is? What's 1 squared?
1, 2.
What's 1 times 1? 1. 1 squared is not 1 times 2. 1 times 1. Okay, and then times 4 is 4, right? So I'm going to go over 1 and down. And that's why I don't care if it's negative or not, right? Because I said it's going down, so I don't care if it's negative or not. Okay? So there's 2 points. Symmetric, so I can put 2 points there, right? Okay. I don't think we can fit another one on there. We'll try. I don't think the next one's going to fit, though. Normally I go 2 and 2 squared, but now I'm going to multiply by. So what's 2 squared? And 4 times 4, yeah, there's no way that one's going to fit. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I made it fit, right? But it's always starting at your vertex. Over 2, down 16. So, and now we can check. Okay? So if I put in 1, I should get, what number should I get? If I put in 1 for x, what should I get for 0? What should I get for y? I just told you. 0, right? So let's try it. So I'm going to get negative 4 times 1 minus 2 squared plus 4. What's 1 minus 2? 1? Negative 1. Negative 4 times negative 1 squared. What's negative 1 squared? 1. Negative 4 times 1? Plus 4? 0. Okay? Right? Did I have to do all that math to figure it out? No, I just had to know that 1 squared was my basic movement, and I'm going to multiply it by 4. Okay? I can do the at 0, because my next point's at 0, even though, you know, if that line continued down, it would be 0. I could plug it in, and I would get, how many ever far down that is? 12. If you do the math, it'll work out. Okay, you guys believe me? Much easier to do it this way, right? It works this way even on standard form once you find your vertex. Once you have your vertex, you just have to go 1, 1 squared, 2, 2 squared, 3, 3 squared, unless there's an A. Much easier to graph if you know the pattern. Okay, do you want me to do another example of this? Vertex form. Yes? Okay. I think, good, I have a graph up here. So let's do one with a fraction, okay? Because you guys love fractions, I know. I know. So let's do y equals 1/3 times x plus 3 squared minus 4. That one's good. That'll keep me on the graph. Yeah, okay. What's my vertex? Negative 3, negative 4. Remember, inside changes. Oh, okay. Is the opening up or down? Up. What's my stretch? H. 1/3. And axis of symmetry? X equals negative. The x coordinate, not what's in here. X coordinate, okay? Okay, my normal movement is over 1, up I'm going to multiply by what? 1/3. What's 1 squared? Times 1/3. 1/3. Excellent. Good. So I'm going to go over 1 and up. No. What did you guys just say? 1/3. Okay. 1/3. So 1/3 of the box, right? 1 times 1/3 is still 1/3. It's approximately 1/3. 1/3 is a little less than half. It's somewhere in that area. These boxes are very small. Deal with it. Okay? So my second one is over 2 up 2 squared times 1/3. So what's 2 squared? And what's 4? Okay. What is 4 times 1/3? 'Which is what? 4/3. Awesome. And what is 4/3 in a mixed number? 1 and 1/3. How many times does 3 go into 4? With how much left over? 1 and 1/3. I'm going to go over 2 and up 1 and 1/3. The next one will be easy. Over 3 up 3 squared. What's 3 squared? 9. What's 1/3 of 9?
3.
Awesome. Over 3 up 3. 1, 2, 3. And there is my, much easier, right? Fractions, how easy was that one compared to doing all the math, right? Okay? Should cut your homework time like in half at least, right? To use this. In 1/3? Okay, in 1/3. All right. Are we good with vertex work? Can we go to intercept form? Yeah. Okay. So it's taking a little longer than 15 minutes. Sorry, guys. I want to make sure you guys get this, though, right? Okay. Because this is going to be big on the CRT, so you got to get this. Okay? All right. What are my intercepts? So this one I'm going to ask pretty much the same questions, except there's going to be one different one. And the different one is going to be x intercepts, and then I want to know what my vertex is. Is it going to open up or down? My stretch, T, H, and my axis of symmetry. Okay? So what are my intercepts?
Is it 2 and 6?
No.
Is it 2 and 6?
-2 and -6. Okay? I can put those on my graph right now. Because they're x-intercepts. They intercept which axis? The x-axis. Which one's the x-axis? This one. Awesome. So -2 and -6. Okay? Sometimes you can just look at the graph and tell me which one is halfway in between those two, right? What number's halfway between -2 and -6? -4. Very good. Okay? Not 4, -4, honey. Okay, so x equals -4. That's my axis of symmetry. I already have that. My vertex is going to be -4. Now I have to do a little bit of math. Okay, on this one I have to do a little bit of math. So I'm going to take this and I'm going to plug it into here. So x plus 2 is, -4 plus 2. -2. And -4 plus 6. 2. And 3 times -2 times 2? -12. So 4 times -12. -4. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. Okay. Label it -4, -12. They want us to label the intercepts. What is that? -2, 0, -6, 0. Okay. Is it opening up or down? We should be able to answer this just by looking. Is it opening up or down? Up. This is positive, so it's opening. What's my stretch? 3. Okay? So I could draw this. Shall we see if it's right? This should be 10, right? Oh, no, 12, right? That's 2 over. So if I move 2 over, what's my normal pattern? 2 over and how many up? 2 squared times, how much is that? Is that 12 from here to here?
Yes.
Yeah. Pattern works. Everything I'm doing in that pattern works, right? I'm going to make graphing and the homework much easier. Okay. Do you want to do another one of these, or are you good with this?
Do one in a fraction.
Yeah, do one of these with a fraction? Yeah, of course. Okay. Oh, wait, was everyone done?
No.
Sorry. Sometimes you just gotta say, Miss Campbell, slow down, man. It's going too fast. Is it making sense, you guys? Manny, you
A little bit.
Are you good?
I like geometry better. I know, it's so much easier. Geometry is easy.
Okay, we good? Luis, good?
Yeah.
Awesome. Okay. All right, so let's see. Y equals -1/4 x -4 and x plus 6. Let's go there. Okay? So x-intercepts, vertex, opens, stretch, axis of, so what are my x-intercepts? 4 and -6. My vertex, we don't know yet. Is it going to open up or down? Down. What's my stretch? 1/4 or -1/4. I'm okay with whatever you put there. And we need to find out my axis of symmetry and my vertex. We have to do a little math for that one, right? I can't just look at my equation to find those two out. So 4 and -6. No, it can be negative. It doesn't matter. Because I use my negative here to tell me it's going down, so it doesn't matter if I put that positive or negative. It's not going to affect how I do my math. Okay? 6. Okay. So halfway between there. Anybody? This one's a little harder just to see automatically. Add those together.
Why?
What's -6 plus 4?
2.
Divided by 2.
1.
-1.
Yeah.
So x equals -1. It's opening down. Okay. Now I need to do a little bit of math, right? So it's -1 minus 4, -5, and -1 plus 6, 5. Ooh, not a good one. -5 times 5, -25 times a fourth. So that's -25 fourths. 4 goes into the -25. -6 times, right? With 1 left over.
Yep.
-6 and a fourth. So I'm going to put -6 and a fourth. -6 and a fourth. Oh. Oh. It's times -1/4, right?
Yeah.
So it's 6 and just a teeny bit up there. Okay? If I go over 1, I go up 1 squared times a 4. What's 1 squared times a 4? 1/4, so I'm going to go over 1, down a fourth, which puts me right there. And really, I only need those 3 points. 5 points. There you go. Okay.
And that's it?
Yeah.
Yeah.
Okay. Not too hard? Can you guys do that? Okay. So we're not, if you haven't done your work for the last 2 times, you should be able to do it now. Okay, because even with the first assignment, which was standard form ax squared plus bx plus c, you can use this pattern once you find your vertex. Every time once you have your vertex, you can do this. Okay? Okay, so you need to get those done. I do have different homework for you today. It's not like a free day where you get catch up on homework. Okay? Oh, there's nothing there. Okay.